Adding and subtracting. Ready? What did we do Friday? We divided and multiplied. So today doesn't make sense, so we're going to add and subtract. Okay? So Friday and today is getting us ready for tomorrow. Okay? Multiply, divide, add, and subtract. That pretty much takes care of all the operations you would have to know, right? So tomorrow and the next day, we're going to solve rational equations. We just have to know how to add and subtract the expressions before we try to solve them, okay? And then later on in the week, we're going to not just solve equations, but we're going to solve equations in real life situations, so word problems, okay? That'll bring us to the point of why we have to know how to do all this stuff. Right now I just have to teach you how to do it so that later on we can work on why we need to know how to do it. Does that make sense? Okay? So, when is the first time you added and subtracted fractions? Third grade? Third or fourth grade? Something like that? So you guys are like experts at it then, right? Because you've been doing it for a long time? No, because as you become more mature mathematicians, you just use the calculator all the time, right? Okay, so we need to know how to do this by hand, because while I can do this in the calculator, I can't do this in the calculator. Okay, so I'm going to take you through the steps of how to do this so that we know how to do this. Does that make sense? Yes. So, tell me, what steps are we going to take to add these two fractions? I'm okay with that as long as you'll use a little bit more clear mathematical vocabulary. Add enumerators. Why can we just add the numerators? Because we have a common denominator. When we add the numerators, what do we do with the denominator? Leave it, right? So first of all, we can add the numerators because we have a common denominator. And we're going to leave it alone. Okay? I think this is supposed to be an M. I don't really know what happened with my pen. Could you just know that it's an M? Are you okay with that? Okay. It's like common denominator. So if I'm going to leave my denominator alone, what is this right here? 7. A 7. And what do I do with the numerators? So what is 3 plus 2? 5. Guess what that is? Yeah, the answer. We're done. How is it different when we have rational expressions? So how is it different then? It's not, right? Okay, it's not. So I have a common denominator, so I'm going to leave it. And I need to add my numerators. What is 2 plus x? Oh no. Try one more time. What is 2 plus x?
3x.
Yes. What is 2 times x? 2x, right? 2 times x is 2x. What is 2 plus x? Just 2 plus x, right? So why did he say I should write x plus 2 instead of 2 plus x? Would it be wrong if I wrote 2 plus x? No, absolutely not. But normally we put it in order, right? We put our variables first and then our constants. You okay with that? So guess what this is? The answer. And we just go on to the next one, right? Okay. Okay. What do I do with the denominator? Okay, so x squared minus 1. And what do I do with the numerator? Add them. Okay, so 2x plus 5x. 7x. Negative 3 plus 7. 4. Guess what this is? The answer. What's the most common reaction, do you think, when I say today we're going to add and subtract fractions? Panic. Right? Oh no. Right? Like, why am I trying to kill you? And that's what normally people ask. Okay, well, first of all, I'm not trying to kill you. If I was, I would succeed. Okay? Although, just for the record, after the basketball games Friday night, I spoke to several parents at the basketball games, and I now have permission to beat 5 more of you.
Oh, facts.
Yeah. Yeah.
You can beat me.
Like people, like parents are like, if he gets out of line or if she gets out of line, just beat them. Okay. I probably won't, just for the record, right? But I have permission to. That was a little terrifying. Okay. But usually the result when I say add or subtract fractions is you panic.
This is Kingston.
Yes, ma'am?
At the end of the instruction, may you please send Aubrey Jones to the office?
I had her last period, Miss Soul.
Oh, thank you.
Yes, ma'am. So, what's rule number 1? Don't panic. Right? Don't panic. Anytime I give you rules of what we're going to do, the first rule is always don't panic. Okay? Look at problem number 2. How is it different than the one we just did? It's subtraction. So, do you think that if it has a common denominator, we should leave it? Common denominator. Leave it. What do you think we should do with the numerators? Subtract. So I'm leaving the denominator alone because it's a common one. And what do I do with the numerators? 8 minus 3? 5. Done. How is it different if I have rational expressions? It's not. Okay? Now, there are some things that I have to be a little bit more careful of, just for the record, but it's the same steps, right? This is a common denominator, so I leave it, x plus 6. The numerators, I subtract them, 2x minus x, and then what? So I'm really glad you said that. I'm really glad you said plus 2. Because what I've heard, what do you think I've heard right here? Plus 20. Because 11 and 9, isn't that 20? What did they forget? The subtract, right? But isn't it easier to forget to subtract the second terms? Because I'm not looking directly at the subtraction sign, but you have to remember we are subtracting, okay? And it is plus 2 because it's 11 minus 9. That's plus 2. Now, what is the most popular incorrect thing that people try to do right here? Simplify what? The x's. They try to cross out the x's. Can we do that? No. Shame. Shame. Right? That's parts of numbers. We can't do that. Do you remember me showing you this example? You remember that? 17 over 19? That's ridiculous. So we can't do it here either. Okay? For those of you who weren't here on Friday, this is what I showed them. If I can cross out these x's, I can also cross out these 1's. And these vertical lines here, so my answer would be this. Isn't that ridiculous? It's completely crazy, right? Except that's what you're doing if you're trying to cancel out these x's right here. Okay? So first of all, we're more mature mathematicians. We talked about that at the beginning of class. We're more mature mathematicians. So we don't even say cancel anyways. We say simplify, right? We're simplifying our common factors. And there's not a common factor in the numerator and in the denominator. There's an x plus 2 and an x plus 6. Those are not common, are they? One is x plus 2 and one is x plus 6. For them to be common, they have to be exactly the same. So we just have to leave it. Okay? If this was x plus 2 and this was x plus 2, could I simplify it? Yes. Right? But since it's not exactly the same, that's just the answer, isn't it? Okay? All right, look at the next example right here. Why do I start with the denominator first? Every time we've talked about this, why have I started with the denominator first? It's the same, so I don't mess with it, right? So I just go ahead and rewrite it, 3x squared minus 4. And what do I do with the numerators? Subtract. Do it. Tell me what it is. What?
8x.
Try one more time. Negative 8x, right? Because it's 1x minus 9x. That's negative 8x, right? And then what? Plus 10. Yes, because it's 3 minus a negative 7. And 3 minus a negative 7, it's 10. Does that make sense? Okay. All right. Look at number 3. How is number 3 different? Ooh, there's not a common denominator, is there? Okay. So before we go any further, I want to talk real quick. We're going to take a quick commercial break. Okay. I want to talk real quick about what it means to have a common denominator. Okay. What I'm going to ask you to do in just a second is find the least common denominator. And what I want you to remember about when you have to find the least common denominator is that we're not trying to find what number they're both divisible by. We're trying to find what number they both divide into. Which means even though the word least is there, it's going to be the smallest number that they can both divide into, which means it has to be as big as the biggest one that's already there, if not bigger. People get confused by the word least. They think it needs to be a small, tiny number. And we want it to be the smallest number that it can be. Otherwise, we'll have to simplify later on, which is fine. We can do that. But we need to find the smallest number they both divide into and not both divide by. Does that make sense? Okay, then look at this. I have 3 over 8 plus 1 over 4. So if I'm thinking between 8 and 4, what is the least common denominator? What is the number they both divide into? 16 would work. Is there a smaller number that they both divide into? 8. Remember what I told you? It has to be at least as big as the biggest one, if not bigger. Now, some people said 2. And the part that you're confused about is you're thinking about the number they're both divisible by. Do you see what I'm saying now? Do you see my word choice, my semantics? Okay? I need to find the number they're both divide into, which in this case is 8. 8 divides by 8. 4 divides into 8. 8 divides into 8. Okay? Now, what do I have to multiply by 8 by to make it become 8? Just 1, so I leave the denominator or the numerator as well as numerator alone as well. Or, like you said, I multiply it by 1. 3 times 1 is 3. What do I have to multiply 4 by to make it become 8? 2. Did you hear what I said? What do I have to multiply 4 by to make it become 8? Because some people will say, well, if you add 4, that becomes 8, right? But we're talking about factors here, aren't we? If we're talking about factors, I need to talk about what do I multiply. Okay? So if I multiply 2 by 4 to make it become 8, what else do I have to multiply by 2? The numerator, right? If I multiply the denominator by 2, I have to multiply the numerator by 2. So what does that become? 2. Now that I have a common denominator, what do I do with it? Leave it. And what do I do with the numerators? Add them. What do you get? 5. 5 over 8. So how are we going to write our steps? Good. Find a common denominator. And then what? Then we do what it says, right? Either add or subtract. Notice these examples over here. One is add, one subtract. So after I find a common denominator, then I add or subtract numerators. Whatever it says to do, right? So when I go to decide between 3x and x what my common denominator is, remember that it has to be at least as big as the biggest denominator, if not bigger. And I think you'll understand the if not bigger part in a second. Okay? But between 3x and x, what would be my common denominator? What do they both divide into? 3x. Okay? Another way to think about it is, if I say it's 3x, can I multiply something by this to get to 3x? Can I multiply something by this to get to 3x? Yes, right? A 3. Now, some people were just saying it's x. Well, what do I multiply this by to make it become just x? Like a fraction. Yeah, we're already working with fractions. You want more fractions? Oh, no, right? And some people were saying it's just 3, right? Well, what do I multiply this by to make it become just 3? Well, nothing. That's smaller than the original, right? So it's got to be at least as big as the biggest one, if not bigger. So what did I have to multiply 3 by to 3x to make it become 3x? 1. So I multiply the top by 1 as well. What do I have to multiply this by to make it become 3x? 3. So that means I have to multiply this whole numerator by 3. Now I have two choices at this point. In the numerator right here, I could write 3, open parentheses, x plus 1, close parentheses. And then I would have to do another step right over here where I multiplied that 3 out. Or I can multiply that 3 out right now, and that's what I write in the numerator. Are you okay if I do that? So I'm kind of skipping a step here, but it's like a natural step to go to. Yes? So what do I get in this numerator right here? 3x plus 3. Excuse me. Now that I have a common denominator, what do I do with the numerators? I add them, right? I either add or subtract, whatever it asks me to do. This one's asking me to add. So I have 5 plus 3x plus 3. What do I get? 3x plus 8. What do you think is the most popular incorrect thing that people try to do right now? Yeah, they want to cross those out, right?
Yeah.
Can we do that? No, that's ridiculous. Just like that. Right? You know I'm not making fun of you when I say that's ridiculous, right? I'm reminding you that you're trying to do that. We can only simplify common factors. This has something being added or subtracted to it, so I can't simplify that. Okay? Okay so far? All right, what about this next one right here? In order to figure out the common factors, or the common denominator, I need to know all the factors. These are easy to see because this is a 3x and this is an x, right? I can't really see all the factors here to know what's common to begin with until I factor all of the denominators if there's something I can do to factor it. This one up here I didn't need to because I could see the factors. What do you notice about this denominator? Both of the terms are divisible by 2. So if I factor out a 2, what's left? X plus 2. Now do you see something common in these denominators? So what do you think our common denominator should be? Think about what our common denominator was here. It should be 2 times x plus 2. Remember, it has to be at least as big as the biggest one. And the biggest one, they both have an x plus 2, so we know that has to be there. But this one also has a 2, so we know that has to be there as well. Okay? So this was already 2 times x plus 2, so I leave the denominator as alone as well. Excuse me, the numerator alone as well. This one was only x plus 2, so what do I have to multiply it by? A 2, which means I need to multiply the numerator by 2 as well. Oops. And what does that put in this numerator? 18. So I have my common denominator as 2 times x plus 2, and what is my numerator? Yes, because it's x plus 1 minus 18, so 1 minus 18 is a negative 17. Everybody okay so far?
Yes.
Any questions so far? We good? All right, now we have number 4, the last example here on the front of this page.
Yes.
What do you think the common denominator is? Remember how I told you earlier it's got to be at least as big as the biggest one, if not bigger? And I told you maybe you'll understand the or not bigger part in just a second. Well, now it's just a second. Okay? 7, right? We chose the bigger one up here. Do we just choose 7 as 5 divisible into 7? No. What's the number that's divisible by both of these? 35. So when in doubt, what should you do with your denominators? Multiply them together. Okay? We could have done that right here. We could have had 32 as the denominator. That would have worked. Now when I got to here, this wouldn't be the answer. I'd have to simplify it to be 5/8, but it would still work because we want to find the least common denominator, but a common denominator will work, and we can just simplify after that. Okay? How do we get from 7 to 35? Multiply by 5, so I have to multiply the numerator by 5, and it becomes 15. Very good. How do I get from 5 to 35? By 7. So I multiply the numerator by 7, and that gives me to 14. What is 15 35ths plus 14 35ths? 29 35ths. Yeah, that took a little longer than I expected, but that's okay. We got there. We got there. Okay? Guys, what steps did we just take? Oh, they're the same. So is arrows okay? Those same steps can be right there. Okay? But I do want to write this when in doubt. What did I say? When in doubt, what?
Don't freak out.
Okay, well that rhymes, but what did I say when this multiply denominators together to get the common denominator? Okay? So what do you think the common denominator is going to be between x and 3? 3x, absolutely. So what do I have to multiply x by to get to 3x? 3, so I have to multiply the numerator by that as well, so I get 15. What do I have to multiply 3 by to get to 3x? An x, so I have to multiply the numerator by x as well, and this time I get, very good, 2x squared. Now I need to do what it asks me to and subtract. Up here, it said 2 plus x, and I wrote x plus 2, right? Right here, can I just write 2x squared minus 15? Is that the same thing? Oh, it's not, is it? Because it matters what order we subtract in, right? We know this is a subtraction problem. We normally want to have our x term first, but is 15 minus 2x squared just a perfectly acceptable answer? If I wanted to write my x squared term first, I would have to write negative 2x squared plus 15. So sometimes it's just easiest to write it in the order that it was already in. Does that make sense? Can I cancel these x's? No. Okay. All right, last example on this front page, right here. What do you think the common denominator here is going to be? Remember how on Friday I said don't make it harder than it is? But when in doubt, multiply them together. Aren't these two multiplied together right now? They are, aren't they? So what does this first one need? A 2x minus 1. So I have to multiply the numerator by 2x minus 1 as well. So what does the numerator of the first fraction become? 8x minus 4. Very good. Does everybody understand that? I just distributed the 4 here and here. What does the second one need? X plus 3. So we have to multiply the numerator by x plus 3 as well. What do I do with the 7? Very good. 7x plus 21. Now what's left to do? Add, right? Exactly what it asks me to do. I'm going to leave my denominator the same since it's common now. I have 8x plus 7x. And I have negative 4 plus 21. What's that? 17? Yeah, I love it when they shout out the answer after I already wrote it. It's awesome. Any questions so far? Okay, one more example that I want to do for you is number 6. Okay, number 6. Does everybody see number 6 right here? Okay, so when you look at this for the first time after we've been doing all the easier stuff on the front, this looks like a mess, doesn't it? And what do you think the most popular thing that people do right here is?
Freak out.
Yeah, they freak out. But remember, what did we do here before we even started? I factored my denominators to see what the factors were to begin with. So let's factor this denominator. What do I get when I factor this denominator? What multiplies to be 12 and adds to be 7? 4 and 3. Is there anything I can factor out of this denominator? They're both divisible by 2, weren't they? So if I factor out a 2, what's left? X plus 4. Oh, okay, so that should make you kind of excited. Why should that make you excited? They both have an x plus 4, right? If they both have an x plus 4, should that be part of my common denominator? Yes. Why did I write a 2? That's weird. Now, remember I said it's got to be as big as the biggest one, if not bigger. So if they both have an x plus 4, I can ignore those for a second. What does the first one have a factor of that the second one doesn't have? X plus 3. That has to be part of the common denominator. Does the second one have something that the first one doesn't have? A 2. That also has to be part of the common denominator. Common denominators don't have to be something you can automatically see, bam, right away. We can look and see what do they have in common, write that down, that's got to be part of it, and then anything else that's there that they don't have in common also has to be part of the common denominator. So my common denominator for this problem is 2 times x plus 4 times x plus 3. Now, what does the first one need to get to the common denominator? A 2. So if I multiply that by 2, I have to multiply that by 2. I'm going to keep going. You can go. You can watch this video later. Do you want to circle the ones you need to do real quick?
Yes.
1, 3, 6, 8. Like I said, I'm going to finish this example real quick, but if you need to leave, please go. Okay? So the first one needs a 2, so I multiply this by 2, and I get 2x plus 12. What does the second one need? It needs an x plus 3, so I multiply the numerator by x plus 3, and I can distribute 5x plus 15. Now I'm just combining like terms from the numerator and the denominator, or excuse me, from both terms in the numerator. So I have 2x minus 5x, which is negative 3x, and I have 12 minus 15, which is negative 3. Now, I want you to think about this real quick. I could actually factor out a negative 3 and have x plus 1. That's not necessary in this particular problem, but what if this, instead of a 4, was a 1? What if this said x plus 1 up here and an x plus 1 down here? Could I simplify those two? Yes, 100%, absolutely, I could simplify those two, okay? So this happens to be an x plus 1 and an x plus 4, so they are not the same. So this right here is the final answer, but you have to make sure that you simplify anything that you can simplify once you get to the end. Okay?